Hi everyone, welcome to our mathematical modeling course. Let me explain and give an introduction of this course. You may have some questions in your mind like what is mathematical modeling? Why do we do mathematical modeling? Are there any application or real world problems that can be used these techniques? Is this an important? So on. Hopefully, you will find answers for some of these questions. First, let me explain model. What is the model? Why do we use models? A model is a representation or an abstraction of a system or a process. Why do we use models? We build models because they help us to define our problems, organize our thoughts, understand our data, communicate and test that understanding, and make prediction. So now you can understand model is very important. So a model is an intellectual tool. What is mathematical modeling? First, we should think about where these math problems come from. These problems come from the real world. So, we can say mathematical modeling is the link between mathematics and the rest of the world. As some examples, it could be from agriculture, astronomy, energy, transportation, chemical engineering, or any area. So, let me explain this mathematical modeling using some charts. So, think about real world problems. Real world problems can be simplified to the real model. Then go to the mathematical model. Once we have a mathematical model, we can calculate and give conclusions. But most of mathematical models are complicated. How do we solve that type of models? Yes, we can use computer. So we can write a program and make it a computer model. It means we give our data into a computer, then we can do the simulation and give a conclusion. So this is the easy path to solve the complicated problems. Then finally interpret. So in this course we are going to learn the techniques of these steps. Again, when you have a real world problems, you ask a question, you think a bit, and then you refine the question, placing it in precise mathematical terms. Once the question becomes a mathematics equation, you use mathematics to find an answer. Then finally you have to receive the process translating the mathematical solution back into a comprehensible, no nonsense answer to the original question. Now, let me talk about the course. This course will cover both spectrum of modeling problems from optimization to dynamical systems. to stochastic process. You will need knowledge of calculus and all of mathematics as well. If you look at a few first chapters of this book, the book we use, you see we have optimization problems. So you should know how to find minimum and maximum. Could you remember how did you find those in calculus? By differentiation? Yes. If you cannot remember, please go back to your calculus and refresh your memory. This course is organized into three parts corresponding to the three main categories of mathematical models. We begin with optimization models. Yes, first few chapters talk about optimization models, then we go to dynamic models, and finally probability models. And also each chapter of the book we use is followed by a set of challenging exercises. There are real problems. These exercises require significant effort as well as a certain amount of creativity on the part of the student. So I hope you have some idea what we are going to do in this semester and about this course. I wish all the best for everyone. So in my next video, I am going to discuss chapter 1 and explain some examples. Chapter 1 will be talk about one variable optimization. Okay, then I hope to see you all in my next video. Thanks.